Hey, it's W5HRO. I have an update. You might remember my last video. I had determined that when I'm on dummy load, everything works fine. And when I was switching to the antenna, that's when I was still having the problem. Now, I fixed the main number one problem, and that was when I added that relay in the bottom of that supply panel on the bottom of the transmitter that create an AND gate so that, two things have to happen before that other relay comes on. And if the other relay lets off, the other one lets off instantly the same time. So it's like, it's a fail-safe thing. So I don't get any more like flash going across the modulation transformer. So that fixed that main fundamental problem, which is why I damaged the 1625 and everything when it happened, because it was flashing the audio across a dead RF chassis. So anyway, let's see. What I mean is some of the stuff was up, but not everything. The plate supply, RF plate supply was gone. So, and possibly the filament supply, and I'll get to that in a minute. So I thought, okay. So I went to bed that night after I did and I uploaded that video. And I thought the next day, I'm thinking, okay, if it is my antenna, it's got to be one of two things. There's three things it could be, but it's probably one of the two. And the first thing I was thinking, my inverted L right now, I converted my antenna out and back to an inverted L. I added a big long piece of horizontal wire at the top of it to that vertical. And right now I just have like a coil, like 22 microhenries to where it's tapped with the coax, and the rest of the coil was going to ground. And I'm thinking, so what happened was, let me back up. That's the first thing I was gonna do. So I went out there that morning and I unhooked that part of the coil and left the 22 microhenry. I said, let's just leave that. And lo and behold, my VisWire was still like about a 1.2 to a 1.3 to 1 without that other rest of that coil going to ground. It's just on the higher bands it brings down those harmonics way on up, that, like on the higher bands, it brings those things closer down to 50 ohms. Try to get like 1.5 to 1 matches and stuff. But I thought, I remembered back when I had that problem with that RF choke that I had out there, when it was just a vertical and it was shorting out on me when I was on 75 and 40, and I couldn't figure out why I couldn't tune the RF amp, because everything kept jumping around. It'd be fine 1 minute, then the plate current would rise, something would arc, or something would happen, and I found out that choke across the input was shorting. And I thought, well, maybe something like that, maybe that's what was causing the problem. So then I get up that next morning, of course, and I go out there and I do that. I unhooked that. I was going to come in. I turned everything on in the shack. I turned the transmitter on. I let it warm up. I got up that morning. I turned it on. About an hour later, I went out there and I unhooked that thing, and I still had the transmitter on dummy load. So I thought, let me go ahead and just, try to get on dummy load to make sure everything's still okay before I switched back to the antenna. Let me make sure that everything's where it needs to be. And I go to transmit. There's no power coming. I'm like, what the freak? And I open the back door of the transmitter and I look, and that 4400 I had, the filament was gone. It was dead. The thing was, the deck was powered up. It's just the filament was gone. I'm like, oh. And you could see, so when I applied plate voltage to it, it clouded the top of the glass. I just lost the filament in this tube. Now, chances are it's just the tube that itself, it just, that happens. These things do burn out. It happens. So maybe that's what it was. It was just, one of those things that just happened at the wrong time on me. But I wasn't sure. So I put that other iMac back in, and I keyed up, and the plate current's still pegging. I'm like, what in the freak is happening? So then I looked down, and I don't have any grid drive, RF grid drive. I'm like, oh, no wonder I can't dip the plate and get anything down. There's no grid drive, and I'm like, freak. So I'm like, what? How did I lose grid drive? Then I started thinking about it. I had this transmitter in the rack I'm doing all these tests, right? It's upside down. Well, this is the underside. Well, that exciter sits right underneath this thing, and that ribbon cable is right. Maybe it's feeding back from here. Duh, maybe I should put the stupid, put this thing back on, right? The cover, but I was working on it. And I've run tests like that in there before on the transmitter, but maybe this time that's what was causing it. Who knows? But then something else dawned on me. And I finally came across it. And I'm like, I just recently added this relay, so when I'm in idle, I have negative 200 volts on the control grid, the 4400, to make sure that tube stays pulled down. Hopefully it's in cutoff or close enough. I think with normal plate voltage, it's supposed to be like about minus 220 volts on this tube, but minus 200 or 197, whatever the heck it was, that's fine. Then I can leave the keep alive supply on. It puts that small screen in that voltage on the plate and the screen, right, from that keep alive supply. So that's what I'm doing. I thought, well, maybe did that cause a problem with the filament burning out? And then I remembered too, I was in here when I was running these tests. There was one day I plugged this thing in when I had the supply working with the tube, and the tube was upside down. And a couple times when this thing was on its side, maybe I damaged the filament on that tube because I had the thing upside down or on its side or on the wrong side, and it somehow weakened it. Who knows? Chances are it was just one of those freak things that just went out at a bad time while I'm trying to figure all this out, It happens, but it could be because there's something else going on. But I think what I'm going to do is, when I put this rubber on here a long time ago, this is the side that goes against this, right? And I wanted to isolate it from this screen choke. I didn't want any arcing between this. I wanted to make sure that screen choke was isolated from chassis ground and everything. So I thought, let me just put that on there. But I'm going to trim the edges. I'm going to measure this, and then take my ruler. I'm going to go a little bit farther in. I'm just going to cut this all away from the edges, because it's not only the screws are making this thing have electrical contact to the bottom. I'm eventually going to put more holes in this, but for all these years, this has been a work in progress since the late 1980s. So I actually started building it in the early 90s, but I was gathering all the parts for it in the mid to late 80s. Late 80s primarily is when I got the first bulk of the parts for it. Had all the chassis and everything ordered all that stuff, had all those things ready to go. And I already had the cabinet, that silver cabinet, but I was still collecting parts at the time. But anyway, I'm going to put that on. But the one thing that dawned on me, here I digressed again, but at least I covered the other possible reason, is that, I put this negative 200 volt supply, so that negative 200 volts is always going across that control leak resistor to ground, that 20K. And that's where that's where I'm reading that 10 milliamps. It's because of that resistor. And it won't hurt anything. It's going to be fine. I mean, you have to look at it this way. Even though it's in series with the tube, the voltage drop that's creating that current reading on the meter is because of the resistor. It's the voltage drop across that 20K. That's what it is. So anyway, but it dawned on me when I did that, I didn't think it all the way through, because it dawned on me, wait a minute, that means that minus 190 some odd volts is going across, is connected to the control grid, but it's also connected to this terminal. And if I would have touched this thing, the chassis ground, while I was playing around in back, I would have gotten shocked. It wouldn't have killed me. It's only negative 190 some volts, but I would have felt it, right? I mean, oh shit, it would have got me there for a minute, and it would have woke me up really quick. And I thought, wait a minute, that's running through that twin lead to that T368 exciter, and there's a coupling cap, a DC blocking cap that's at the output of that BNC terminal. What's the voltage rating on that cap? And I'm wondering if maybe I was damaging that cap, and that's why the grid drive was lost. And I thought, oh crap. So what I'm going to do is I'm going to get out the T368 exciter manual, or that part of the manual, and I'm going to trace down that part number, see what the value is. I'm probably going to replace it just to be safe, and see what the voltage number is on it, what the voltage rating was on it. Then I'm going to have to, because I sure as heck don't want voltage on this terminal. So I'll probably take the same capacitor and put on this side to do a DC block here. and that'll keep it off the, because I don't want it on the ribbon cable. But see, that's what happens. Sometimes you think you're so smart and you go to fix a problem that you wind up creating another one without even realizing it. And the other thing too is when I lost grid drive, I noticed a relay, when I tried to increase the grid drive knob, a relay was clicking on and off, and I'm wondering if I was getting RF into like maybe this relay too. But I'm going to try, I know I forgot to put, I normally put a diode across the coil, and I forgot to do it when I wired this up. I can take these screws off and I can lift this thing up so I can solder one in there on the, I can like flip it over and get to the bottom terminals. So I'll probably add the diode on that. And I'm going to put the cover on after I add this blocking cap, because when I came out here, I had the T368 exciter out here the other day. It's holiday season. I'm just now getting back on this. I brought it out here like 2 days ago with the exciter rack, which I temporarily, I wanted to get it out of my way because I'm setting up my bench here. I got the computer all going and everything, but when I first came out here, I mean, what I'm saying is the exciter was putting, I had grid drive again. As soon as I came out here and I plugged these guys, I had them all sitting, up the right side up, and I had it connected to one another. I had the one like sitting this way and the other one sitting this side, going that way. So they were back to back, and I was able to get the ribbon cable to connect to the one. And that's when I discovered, oh crap, there's negative 190 some odd volts on that line. But I had grid drive again when I brought it out here, if I can talk straight. I had grid drive when I brought it out here. So it was working again, but maybe that cap, that series coupling cap at the output of the exciter, maybe it's going intermittent or something. But in any event, that could have been the problem. And it could have been just the RF feeding back to the ribbon cable, because I didn't get this thing put. I guess I should have that on there for my test too, but I wanted to be able to see these things lighten up. I wanted to be able to squat down while I was modulating to see how far they were dimming. And, I left it off to work on it, and I was going to put it back on when I was finished, but I guess maybe I can't do that. So, but anyway, the other thing was when I heard those relays clicking, it sounded like the TR switch relay, and I'm wondering, and I've got both those cables, those RCA cables, going down now to apply the 12 volts to that, to the TR switch relays, and then the other one's going all the way back down the ground. Maybe I should put it back the way it was, because I think the relays, they're going to both come up fast enough. Those things don't have to be, the antenna relay could come up, 10 milliseconds or more after everything else is up. It's not going to hurt. It's so much, there's so little time. That's such a little time of an event that it's most of the old transmitters, even like all the commercially made ones, say like the Collins and the Johnsons and everything. I mean, they always turn, what they would do on everything is when you transmit, it would turn the primaries on all the supplies at once, right? Unless it was like for the exciter or something that had to be left powered on all the time. And the timing, that stuff usually wasn't an issue. Yeah, one might come up a little bit before the other. So what? It's not going to hurt anything usually, right? So I mean, that's why I was so surprised I was having that problem with this transmitter, because I never had that problem with it before. So what if one came up a few milliseconds before the other? But I thought, because of the problem I'm having, and at least the way I did that control panel on that bottom of the transmitter on that supply rack, control rack, that at least now I've guaranteed the event to happen the way I want it to. And it's a fail-safe in case the one's gone, the other one lets up, and I won't have that flashover problem. So at least that part's corrected for sure. So basically what's been going on with this transmitter, it's just been, that was exacerbating the other problem is what I'm getting at. It was just making it more noticeable, and I was making it harder to figure out what was going on. So this last part, I just got to make sure that there's not something else that may be causing the filaments to burn out prematurely. I don't know. It probably was just a freak of nature with that tube, or maybe I had it powered up when it was, I had the thing plugged in when I had the deck turned at the wrong, where the tube was at the wrong angle. I think it says in the manual they can be right side up or upside down. They just can't be sideways. I'm trying to remember, or maybe it's the other way, but I've done it all those ways, so maybe that's why that tube, maybe I damaged it by doing that. It was probably stupid doing it that way. I didn't even think I should have removed the tube, but I wanted to be able to check that voltage with the control grid connected, right? And that resistor. So I went ahead and did it, but it may have been a mistake. So anyway, let me, like I said, what I think I might do is I might put that TR relay back the way I had it, to where it's grounded at the relays up there at that box with that shorting plug, and then I just turn the 12 volts on and off. I may hook it back through that relay. That probably is a safer solution, to be honest. So because I think I might have been getting RF on those RCA cables. I had the toroids clamped on the one, but I hadn't put any on the other one, and that could have been, that could have also knocked out the supply, the relay control supply for that other relay, because I was hearing a relay click. I'm just not sure if it was the TR switch relay or if it was the exciter relay. Maybe it was the RF was getting into that RCA cable, and it killed that supply that controls that one relay in the on the exciter, and so I wouldn't have had grid drive if that was the case. That could have been it too. So I just got to narrow it down to figure out what this last remaining problem is. But you saw everything else works fine. I mean, this thing, it was back to life on the dummy load until I woke up the next morning and was going to run some more testing, and it found out that tube was dead. So no filament. Hopefully it was just one of those freak things that just happened at that time, but it's making me rethink everything. That's kind of why I've taken a step back. I was taking my time. I've been busy, was out doing Christmas shopping and all that stuff. So I'm just now getting back on this again. So I just thought it's right before Christmas. What is it, the 22nd today or 20? No, it's the 23rd. Hey, I should know. Windows is telling me, right? And see, I've got all my my little toys here, my little nano VNA. That's how I analyzed my inverted L, and I know exactly where to tap the coil. I found where all the dips are, and I was able to move it around. But then I've got my little, that tiny spectrum analyzer, what they call that, a tiny SA. And I've got, I have the software apps already installed on the laptop and everything, and I have the, what do you call it, the old desktop port, one of those office type things that, the cable plug, I'm sorry, the docking station. The docking station's right there. So anyway, that's leftover stuff from when I'm not working from home anymore. And this is stuff my wife, she works upstairs during the day. She's up there now working. She still works from home, but she's working a couple jobs on that computer. And she had so many, another job she had, and she quit that one. And they didn't want this stuff back. So I set it all up. They didn't even, it was amazing, but apparently it was a small company and they didn't want to deal with the shipping. They just said, keep it. They'll just take it off their network so you can't get into anything, which was kind of wild. So I wound up with it for down here. So anyway, that's kind of the situation. But I've got more dockings. I got another docking station down there too. Because that job I was doing, I'm not doing anymore. I said, I don't need the extra money. So I finally got tired of it. So I let that one go. And I'd worked it for about 2 years, made enough money. And I said, I don't have to do it. I'm on Social Security now, and it's enough. I don't have to worry about it. We have enough savings to be retired forever, I think. So I don't have to worry about it. I may take a part-time job when my daughter graduates from high school or something after she gets out, because I'm getting her Social Security money too. That's the thing. A lot of people are retiring early and they're collecting Social Security and they're waiting to have kids early because they can get that extra money, from claiming their expense, So right now I'm getting about double what I'm going to get in a few more years from now. So that will make a difference. Then I might want to find a part-time job so I can, keep playing with my toys, I'm still trying to get this place cleaned up, but oh, by the way, here I am showing off. TikTok shop, have you seen these things? Everybody needs one of these things. I saw this. I said, I have to buy one of these things. This is the coolest thing. Who wants to get out the big leaf blower, and plug it in the wall, or if it's gasoline powered, it's not this isn't as powerful, but I'm telling you right now, that thing will blow all this. That stuff will blow everything off this bench off the floor. And occasionally when I get all the loose debris off the top of that stuff, I just had no place to put anything else. So I'm going to get a cabinet there with doors on it and get these drawers cleaned out down here. And I'll get, then I'll be able to take this thing and blow all the dust off that stuff, a couple times a week so it doesn't get too dirty, it doesn't build up the cobwebs. But right now there's so much loose stuff on top that I can't, it might blow on the floor and something might break. So I got to be careful. So anyway, here I am, I digress, but let me, I was going to say, yes, December 23rd, tomorrow's Christmas Eve, so I want to say Merry Christmas and Happy New Year, and there won't be another video until after Christmas, I'm sure. I was hoping to get this transmitter back on the air right by Halloween, like in October. Then I thought, I got busy and I finished up, finally got the shop here cleaned up. I was behind in finishing up those projects outside because I had to I just stopped going outside because it got so hot in the summer. It's 100 some degrees every day and you don't want to go out there. So anyway, I got behind on that. So I was hoping to get on. Then I thought, okay, I'm going to get on by, Thanksgiving. Well, then I finally did. I think it was like the day after Thanksgiving, or it was like the Thanksgiving weekend. I think it was that Saturday or Sunday is when I tried. Let me power this thing up, check it without that 1625 tube, because I wanted to hook up that 200-volt supply, and I wanted to get that working and stabilized with the load first. Then I was going to, test it out, which is what I did, and that's when I discovered there was still a problem. So then that's where we are now. And this is what, 3 videos later, and here's where I am on it. So there'll be another one, but it'll be after Christmas. So 73s, this is W5HRO. And like I said, I'll say it now, Merry Christmas and Happy Holidays.